Ever wondered what mysteries lie beneath the fiery surface of our sun? This celestial body's surface is a swirling spectacle of dynamic activity, an enigma that has sparked curiosity for centuries. Its volatile surface, painted with dark sunspots and punctuated by the titanic eruptions of solar flares, is a constant reminder of the sun's powerful underlying forces. As we strive to unravel the sun's secrets, we're left in awe of its astounding phenomena. Today, we delve into two intriguing phenomena: sunspots and solar flares. So, what exactly are sunspots? These dark spots on the sun's surface have intrigued scientists for centuries. They are, in essence, areas where the sun's magnetic fields are so strong that they prevent heat from the sun's interior from reaching the surface. This results in these areas being cooler than the surrounding surface, and hence, they appear dark. Let's decode this a bit. The sun, like the Earth, has a magnetic field. However, the sun's magnetic field is far more complex. It gets twisted and tangled due to the differential rotation of the sun. This means that the equator spins faster than the poles. Now these twisted magnetic fields can sometimes poke through the sun's surface and create sunspots. But why are sunspots cooler? It's because these strong magnetic fields block the upflow of heat from the sun's interior to its surface. When the heat is blocked, these areas become cooler and thus darker than the surrounding areas. They are still incredibly hot, though, with temperatures around 3,500 degrees Celsius. It's just that the surrounding areas are even hotter at around 5,500 degrees Celsius. Then there's the sunspot cycle, a roughly 11-year cycle where the number of sunspots increases and then decreases. This cycle is an essential part of understanding the sun's magnetic activity and its effects on Earth. While they might seem small from our vantage point, remember, some sunspots are even larger than Earth. Now, let's turn our attention to the explosive solar flares. Imagine a sudden, intense burst of energy erupting from the sun's surface, like a fiery whip lashing out into the cosmos. This is a solar flare, a phenomenon that is as spectacular as it is powerful. These flares are the sun's way of releasing excess energy, specifically magnetic energy, that has built up in its atmosphere. But what causes this magnetic energy to accumulate in the first place? Well, it's all down to the sun's complex magnetic field. The sun is not a solid body. It rotates faster at its equator than at its poles. This differential rotation, as it's called, twists and tangles the sun's magnetic field lines, creating knots of magnetic energy. When these knots become too strained, they snap, releasing a colossal amount of energy in the form of a solar flare. Now, these solar flares are not just an awe-inspiring celestial spectacle. They have a profound effect on our own planet as well. When a solar flare occurs, it hurls a cloud of electrons, ions, and atoms into space. This stream of charged particles, known as a solar wind, travels across the solar system at a staggering speed of around 1,000,000 miles per hour. When this solar wind reaches Earth, it can cause a geomagnetic storm, a disturbance in Earth's magnetic field. These storms can have a variety of effects, from creating beautiful auroras to causing power outages. They can also disrupt satellite communication, GPS systems, and even astronauts aboard the International Space Station. But it's not all doom and gloom. Scientists are working tirelessly to better understand solar flares and predict when they might occur. This knowledge could help us mitigate the impact of these solar events on our technology and infrastructure, ensuring that we are better prepared for the sun's fiery outbursts. Solar flares, then, are not just spectacular to observe, but also have significant impact on our planet. Let's recap what we've learned about these solar phenomena. Sunspots, dark and cooler areas on the sun's surface, are not just fascinating to observe. They are key to understanding the sun's magnetic field. These spots tell us that our sun is a dynamic and ever-changing star. On the other hand, solar flares, those spectacular eruptions from the sun's surface, are a testament to the sun's immense power. They can release energy equivalent to millions of hydrogen bombs. These flares can affect our technology here on Earth, influencing everything from our satellite communications to our power grids. Studying these phenomena is not just about satisfying our curiosity. It's about understanding the star that sustains life on our planet. It's about preparing for solar events that could impact our daily lives. The sun, with its sunspots and solar flares, continues to be a source of fascination and discovery. As we unravel its mysteries, we unlock the secrets of our solar system and beyond.